I'm Ann Paczula, and I'm presenting Color Science from Chapter 8 of the book Design for Hackers by Daniel Kadavy. This presentation covers defining color, thinking in hexadecimal code, and color models in action. Early efforts to define color led to the models we use today. Munsell defined color based on three axes: hue, value, darkness or light, and chroma, or color intensity. Munsell's model was the basis for the modern-day color models HSB, Lab, and HSL. This table shows how the Munsell, HSB, and HSL color models align with and differ from one another. Each model defines the hue, which means a pure color. Saturation is like chroma and refers to the intensity of a color. Saturation is measured differently in the HSB and HSL models. Brightness and value carry information about blackness, while lightness conveys information about black and white. HSB breaks down the representation of color along the three axes of hue, saturation, and brightness and divides them into equal ranges. This is a distortion of human color perception. However, it is the most intuitive tool for picking a color that comes to your mind. HSB is commonly used in color pickers, which are a tool found in graphics programs or online to select colors that you see on your computer monitor. Another common color space is CIE Lab, commonly known as Lab. L refers to lightness, A refers to the opposing pair of red and green, and B references the opposing colors blue and yellow. Like HSB, Lab is the basis of some color pickers. Lab is considered the most accurate model of human color perception. Some problems can arise when choosing colors to use in data-driven graphics. Lab is the best color picker to use for qualitative data because you can select different colors of equal lightness. Keeping lightness constant among different colors in a qualitative graph will prevent people from attributing a superior or inferior value to different categories. When HSB or HSL is used to pick colors for numerical or quantitative data, some of the colors may have different lightness measurements but are hard to distinguish from one another. To create a graphic using perceptually distinct colors, try using a handy tool called Color Brewer. RGB is the basis of the hexadecimal system. In computer monitors and TV screens, projected lights in red, green, and blue mix together to produce colors. This is an example of an additive color model. This graphic shows the colors that result from mixing the primary colors together. Hexadecimal numbers are used in web color coding. They consist of a pound sign followed by 3 pairs of digits. The number pairs indicate how much red, green, and blue is in the color. Each number pair counts from 0 to 15 using the digits 0 through 9 and letters A through F. The lowest value, 00, indicates the lack of that primary color, red, green, or blue, while FF, the highest value, means full strength of that color. This chart displays how the absence of the red, green, and blue results in black, and the maximum value of each results in white. It also shows how red, green, and blue are represented in hexadecimal codes, and how mixing them results in yellow, cyan, and magenta. In cascading style sheets, hexadecimal codes can be shortened to 3 digits as long as each hex pair is the same. So black, which is 000000, can be shortened to 000. Once a hex code is 3 digits, it is easier to fine-tune to find the desired color. You may want to explore hex codes by creating various shades of gray. For example, you may try 999, which is a medium shade of gray, or CCC, which is a lighter gray. If you'd like to try your hand at adjusting hex color codes, go to www.colorhexa.com and input either a 3 or 6 digit code. Then adjust one pair of hex codes at a time to see what color you end up with. The process of producing colors on a screen is different from print models of color. While screen colors display from a combination of red, green, or blue lights, color printing results from a combination of cyan, magenta, yellow, and black ink, known as CMYK. CMYK is a subtractive color model. While the RGB color model has you add colors to create white, CMYK starts with white, then you subtract from it to create different colors. The colors you choose to use are limited by our visible spectrum, as well as by the range of choices available in your chosen medium, whether it is computer monitor or print. This boundary of color capabilities is known as a gamut. RGB and CMYK have different gamuts, as illustrated by the graphic. This means that Not all the colors you see on your monitor can be reproduced on a color printer, and vice versa. In order to maintain consistency across different color spaces, gamuts are described by an ICC profile that can be attached to your graphic file. This profile is just one option for translating the color across color spaces. This concludes the chapter on color science. Please refer to Chapter 8 in Design for Hackers for more details on these and other topics.